Notation! We're going to talk about scientific notation right now, okay? Scientific notation, it is a way to communicate very large or very small numbers. Look, you got a few very large and small numbers here. What's the significance of each of these numbers? If you go back a couple of pages at the bottom of the extra notes page for section 4.1, there's a little cheat sheet there for these, okay? The first one is called Avogadro's number. You don't need to write it down. You do not need to write it down. Avogadro's number is a scientific number in chemistry. It means the number of molecules in a measurement called a mole, M-O-L. Say woo if you've ever heard of Avogadro's number. Woo. Interesting. I'm impressed. Okay, very good. This next number down here, this is the average number of brain cells in the human brain. Okay? Average number of brain cells in the human brain, you know? Get a few concussions, you got a few less. You know, smoke a few doobies, you got a few less. But yeah, hopefully you got all those there, and you're all staying clean in your lives. This right here, what is it? It says it's the weight in kilograms or the mass of what? Say, did you look up your little cheat code? No, you looked up the cheat code? It's at the bottom of the extra notes of 4.1, the previous section, not this section.
Proton? Electron?
It's the weight of a cell or something in your body in kilograms. But what kind of a cell? Does it say?
Brain cells?
Does it say? What does it say? The mass of a proton. The mass of a proton. Sorry. Okay. Mass of a proton in kilograms. All right. Look at this, please. The definition of scientific notation is found in the first step right here. It is a number that only has one digit to the left of it. It's a number that only has one digit to the left of it, and that digit can't be 0. And then the rest of this kind of defines it as well. So this three-step process is how we put numbers into scientific notation. So we're going to put these three numbers into scientific notation, talk about this, and let you do a few, and then we're going to move forward rapidly, okay? Move the decimal so there's only one digit to the left of it. So the first one, I'm going to write on the board with you. The other two, I'm going to let you do them yourself. So look up here. We got 6, 0, 2, 6, 8, 9, 10, 11. Okay, that is Avogadro's number. Okay, not avocado, Avogadro. Okay, where's the decimal right now?
At the end.
At the end. Works for me. Right there. Okay, that is the decimal, indeed. And we're going to move that decimal. It says, step number 1 here says, move the decimal so there's only one digit to the left of it. Right now, how many digits are to the left of it? Well, a crap load of digits, man. So let's move this decimal, okay? Here we go, loop-de-loop. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Do I stop there? Do I stop there?
No.
21 there?
No.
Yeah?
Yes.
22? Do I stop there?
Right, 6.
23. Yep, it's 6.02 times 10 to the 23rd. That is the scientific notation of Avogadro's number, 6.02 times 10 to the 23rd. Some of you have that memorized. Please look up here. Okay? Look up here. We moved the decimal so there was only one digit to the left of it. Those of you who wanted me to stop here, look at me. I don't know why you wanted me to stop there, because I guess you decided that once we got past the zeros we were going to stop. But that leaves us with 3 digits to the left of the decimal. You can only have one digit to the left of the decimal, and that digit cannot be 0. Okay? So we got to move it all the way to the 6, so there's only one digit to the left of it. Okay, the second step says we're going to take this new number. The new number is 6.02. That's the new number. That's the new number that you created by moving the decimal, and you're going to multiply it times 10 to the number of places that you moved, the number of decimal places you moved. Right? N stands for the number of decimal places you move. Now, is N going to be positive or negative? Well, that's a decision that you have to make. If we move the decimal to the left, it's positive. If we move to the right, it's negative. But for those of you who get left and right mixed up, you can teach yourself that if the original number was more than 1, then N will be positive, and if the original number was less than 1, then the number will be negative. Okay? What was the original number? More than or less than 1? It was a lot more than 1. So, indeed, N, or this little decimal, this little exponent up here ended up being positive. You cool? Let's do this one together. Please look up here, okay? Look at me. Do it together in your book. I want you to make the loopy-loops. By the way, it says right here, count places moved, not zeros. If you counted zeros, at this point you would have had 21. At this point, if you added that 0, that'd be 22. It was 10 to the 23rd. It has nothing to do with the number of zeros. It has to do with the number of decimal places moved, okay? N stands for number of places moved. Okay, so let's go ahead, let's move this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more makes 8.6
Times 10 to the
times 10 to the 10th. Very good. It's a positive 10 because the original number was more than 1. Let's do this mass of a proton one, okay? This one we're going to have to really keep track of this. So do this in your workbook with me. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Holy crap. 22, 23, 24, 25, 26. Do I stop there? 27. Do I stop there?
Yes.
I do.
Wait, where do you?
So look at this. It ends up being 1.673 times 10 to the 27th. Say woof, you got it right. Woof, but it's not to the 27th. It's to the negative 27th because the original number was less than 1. Or we move the decimal to the right, whichever you want to memorize, but you've got to memorize one of those in order to understand whether it is negative or positive. Now, look up here, please. Some of you were, look up here, wanting to keep going further. Okay? It's not one digit to the right, it's one digit to the left. And once you got past the 1, you had one non-zero digit to the left of the decimal, and you stopped. That's the definition of scientific notation. You can only have one digit to the left of the decimal. That digit cannot be 0. We cool? All right. Scientific notation is the only time that keeping negative exponents is not only acceptable, but expected, okay? Because a negative exponent communicates that the number is very small, all right? In all of our other work, remember the negative exponent rule says we can't have them, we got to get rid of them, right? So we see something like this problem right here, 3.05 times 10 to the negative fifth, 3.05 times 10 to the negative fifth, and normally when we do something like this, we would say, oh yeah, that's 3.05 over 10 to the fifth, right? Because we would say, well, 3.05 is to the positive 1, so it stays up there, but this is to the negative, so we got to bring it down. Okay, no fumar, don't smoke that dope, okay? That's wrong. Okay, we don't do that in scientific notation. We leave it in its negative exponent form because we are communicating that it is a very small number. We cool with that? Okay, so scientific notation is the only place where we can keep negative exponents and feel okay about that. All right? Now, how do we know it's scientific notation? Well, we just saw this whole kind of format here. The number times 10 to the number of places moved, right? Cool? Let's go to the next page. Is this making sense? Is this hard or easy?
Easy.
It's easy. Okay. On your own right now, I want you to convert these problems to scientific notation. I'm going to give you about 2 minutes. You're going to be able to rip through these fast. Problems 1 and 2, convert them to scientific notation. And problems 1, 2, and 3, convert those to decimal notation. We will go over the answers here in a minute. Let's go ahead and pause. So the question being asked right now is, why is, if I have, 3 or 5.0 times 10 to the 7th, why is that to the 10th? Well, think about this. 10 to the 1 equals 10. 10 to the 2 equals 100. 10 to the 3 equals 1,000. 10 to the 4 equals 10,000. And how do we know this? Well, 10 times 10, right? 10 times 10 times 10, right? This is that, expanded form, evaluated form, right? These are the evaluated forms. This is the exponential form. Here's the expanded form. Well, think about this. How many zeros? 4 zeros. How many decimal places? 4 decimal places. A power of 10 is worth a decimal place. That's why.
Yeah.
Cool?
Yeah.
Good question. Really good question. So, help me out here. The first problem up here, everybody, we end up with 2.15 to what?
10 to the negative.
Okay, you had to move that decimal over how many places? 9 or 10?
9.
Okay, you guys are made to make me count this. Okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 2.15 times 10 to the 9th. Okay, and it was
Is it
negative 9 because
Less than 1.
you moved to the right, or the original number was less than 1, right? You cool? Okay. Next one, 3.65 times 10 to the what? 14. Okay, we are in agreement on that one. That is 14. We cool with that? Everybody agree with 14 on that? very good. All right, now we're going to convert these to decimal notation. I've got Grace sliding back and forth with the camera here. We got 10 to the 7th. Okay, so let me share something with you about 10 to the 7th. We put that up there to kind of mess with your minds just a little bit. This goes back to the whole power of 10 thing. Okay, in essence, this is 1 times 10 to the 7th, because 1 times anything remains the same, which is also 1.0 times 10 to the 7th. So you're taking 1.0 and you're moving the decimal 1, 2, 3, 4, 5, 6, 7. And I like to draw those little loop-de-loos because then I just fill them all in with my zeros, right? And this ends up being 10 million. And so if you got 100 million, you went too far, right? So it's 10 million, okay? You guys cool? Okay. Then we got, because ultimately, remember, scientific notation is a number times 10 to the n degrees. And so our number is 1, so we're moving the decimal from 1, not from 10. 10 is not where the decimal is moving. It's the number in front of the 10 that is where the decimal is moving. 5.702 times 10 to the negative 6. 5.702 times 10 to the negative 6. So notice on this one I moved it to the right because I need my number, see, because this is positive, I need my number to be bigger than 1. This one is a negative, so I need my number to be less than 1, so I'm going this way. 1, 2, 3, 4, 5, 6. 0.000005702. You should have 5 zeros in front of this 5702, right? You guys cool with that? Say what if you got it right. Okay? And then we have 1.95 times 10 to the 8th, 1.95 times 10 to the 8th. And we're going to take 1.95, we're going to move that 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go 0, 0, 0, 0, 0, 0. Did you get 6 zeros after that? So you ended up with 195 million. Cool? Okay, very good. All right, so sometimes when we're doing scientific notation, they'll have numbers in scientific notation that are being multiplied or divided. And when that happens, we follow this little process here where we take the numbers with the numbers and the base 10 with the base 10. Let me show you an example here of this one, and I'm going to have you do the second one on your own. Okay? 3.0 times 10 to the negative 12. 3.0 times 10 to the negative 12 over 6.0 times 10 to the what? 20th. Okay. All eyes up here, please. Okay. So on the portion where it says numbers with numbers, that's where we take 3.0 and we divide it by 6.0 and we just focus on that. What's 3 divided by 6? It's 0.5. Okay, put that in the calculator. Right? You see what I'm doing? I'm divorcing. I'm literally kind of, divorce means to break. Okay? That's what it means, right? So divorce is not just a term for marriage. It's anytime something is united, you're breaking it. Okay? So you take this, and right now it's all united, so we're breaking this. Okay? And we're divorcing the numbers from the base 10s. We're just dealing with the numbers with numbers, and the base 10s with the base 10s. So now I take the 10 to the negative 12, and the 10 to the 20th, and I simplify this expression. Well, they have the same what? Base. Because they have the same base, they're being divided, the laws of exponents say I can subtract them, so that equals 10 to the negative 12 minus 20, which makes 10 to the negative 32. So now I have 0.5 times 10 to the negative 32. And you say, oh good, I'm done. No, you're not, because the definition of scientific notation stated on step number 1 of the previous page that we can only have one digit to the left of the decimal, but that digit can't be
0.
So is that in scientific notation? No. Okay, I want you all to drop your pens and pencils. Make sure you look up here because I don't want to lose you. I want you to understand this concept. It's pretty important, okay? Forget about this right now. Forget about it, okay? Don't worry about that. Just talk about this right here. 0.5. If I convert 0.5 to scientific notation, I'm going to move this one place. That's going to be called 5.0 times 10 to the what? How many places did I move it? One place. And the original number was less than 1, so it's 10 to the negative 1. We cool? Yeah. But we already know that that is also times 10 to the negative 32. So now these two can combine because they have the same base. They're being multiplied. We can add those. So this ends up being 5.0 times 10 to the negative 33. Now I do get students sometimes and they say to me, Brother Rich, why didn't you just add 1 to this? Well, I didn't just add 1 because if I added positive 1, it'd be negative 31. I took the time to convert it so I can make sure that I do it correctly. Okay? If you can do it in your head, that's fine. But if you do it in your head and you get it wrong, then that's not fine. Yeah? You guys good?
Yeah.
All right. Is this stuff hard or easy? You know, overall, scientific notation is pretty straightforward. Why did we wait to learn scientific notation until now? Well, because we had to know how to handle exponents, right? The laws of exponents. Yes?
I
Do the next problem.
I answered this myself. You can't have 0 on the left. So
You can only have one digit to the left of the decimal, but that digit can't be 0. Let's just quickly go back to the last page and look at this box here. This is what defines this for us. Right here. See this right here? It says that move the decimal so there's only one digit to the left of it, non-zero. That digit cannot be 0. And we said this is the definition of scientific notation ultimately, right? Okay, now I want you to do the next problem down there where you have 2.3 times 10 to the, what, 5th? And 4.6 times 10 to the 15th. Okay? So you're going to divorce the numbers, right, and from the powers of 10. And you're going to multiply number times number, so you're going to take 2.3 times 4.6. What is 2.3 times 4.6?
10.58.
10.58. Does everybody agree? Say woo if you agree. Very good. Get it on your calculator. Calculator don't lie. Okay? And then you have 10 to the 5th times 10 to the 15th. What's 10 to the 5th times 10 to the 15th? What does that become? It becomes 10 to the 20th. That's right, because laws of exponents, if they're being multiplied, we can add their exponents if they have the same base. So now, is this in scientific notation?
No.
It is not. How do we get it in scientific notation? Very good. Okay, we're going to move this one place. We call this 1.058 times 10 to the 1st because we moved it one place, and the original number was bigger than 1, so it stays positive. And we have times 10 to the 20th, and these two can combine, so I have 1.058 times 10 to the 21st. Say woo if you got it right. Very good. We're done with scientific notation. You have 20 problems in your homework tonight on scientific notation. Can I tell you, that assignment should take you 10 minutes. That assignment should take you 10 minutes to do those 20 problems. It'll be very fast and very straightforward for you. You guys cool? Okay. If I scroll down, show you the assignment. I mean, look, they're going to have you convert some numbers to scientific notation. They're going to have you convert some, scientific notation to decimal notation. And then they're going to have a few of these we just did where they divide and multiply. You might have to convert the final answer back into scientific notation when you're done. A couple of retro problems from in the cumulative section. All this stuff being pretty easy. You guys can handle it, okay? Okay, guys, can I share something with you real quick? The answer is yes, because I'm going to anyway, so you're not going to say, yeah, you can share something, right? Cool. Okay, exactly. So, we've had a discussion before that impress yourself. That's kind of cool. Written right there. Are you going to impress yourself today? I like that. I like that motto. Okay? I already impressed myself this morning. I played basketball. I looked good. I was like, playing like I was 25, but I got the crap beat out of me by those old men, They're just throwing me all over the place like a rag doll, Reminded me of my high school days. The difference is in high school, I'd bounce back up and be like, yeah! Now I get up and I'm hobbling and I'm like, oh, it just hurts, That's what happens when you get old. All right. What I'm going to share with you is that tonight you have a lot of homework, okay? However, every assignment is easy. Now, I once told you that God can be trusted because He is omniscient. He knows all. He knows the end from the beginning. So you can have total faith in your Heavenly Father. So when life seems upside down and you're losing faith, right? You can still believe it's going to work out because you are a covenant making and keeping people. You've made a covenant with God. He's got your back. Okay? So when it gets tough, you can be like, He knows He knows where He's taking me. I can trust in Him. Right? So today I want you to understand that while I am not God, I also know the end from the beginning in regards to this class. And I know where we're going over the next 3 weeks because 3 weeks from today is the last day of class. And we're going to hit some hard stuff. And so when it's hard, we're going to slow it down. But right now it's easy. So we're going to pump the gas, and we're going to fly through these few sections here and just knock them out because it's easy. I'm going to buy you some time when it's harder. And the other thing I'm trying to do, I'm trying to buy you the last day off. I'm trying to give you the last day off so you can just take your test and be done. You got me? Does that sound like a good idea? Okay, but I need your support in this because you got to get this homework done. Okay, I want you just for a second, I want you to turn all the way back to the first page, of this section. It's the title page, chapter 4. Look at this. Notice that it says the laws of exponents and scientific notation. We've got this big old blue bar there separating the rest of this chapter is all about polynomials. We're going to discuss the basics, addition, subtraction, multiplication, and division of polynomials. Now you can go back to where we were, okay? And we're going to go to section 4.3 here. And I'm going to teach you this, and I want to share something really cool. Sometimes in any subject, we hear a big word and it intimidates us. Calculus, differential equations, and even a word like polynomial can be intimidating because it's just like, what does that mean? That's just so scary sounding, right? So first of all, let's understand that a polynomial, what does poly mean? What does poly mean? It means many. It means many. So write many underneath poly, okay? Multiple is true too, but let's go ahead and write many. Multiple or many, they're both the same thing. Multiple or many, more than one, okay? Next thing, ready for this? Nomial. Nomial. Does anybody speak French in here? Any French speakers? Parlez-vous français? No? Si? Oui? I got Spanish and French going on here, okay? All right. What does the word nom, N-O-M, mean? Name. Very good, okay? So we see up here nomial, all right? The science of giving things names is called terminology. If you give something a term, it's like giving it a name. So terms and names are really synonymous with each other. So literally translated, polynomial means many terms. Write that down. Many terms, okay? Or many names. We're going to say many terms, okay? So we're going to call polynomials polys for short. If you have Polynesian blood in you and you're offended by this, I'm sorry. I love the Polynesian people. I've been adopted into that family, and I'm telling you right now, they're the coolest ever. They call each other polys for short, and we're going to call polynomials polys for short, and it's just almost like an offense to me. It's like something as nasty as this math, and we're calling it polys, but we're going to do it, okay? Look up here, please. Right here says polynomials basics. Says most of this you know. Notice it doesn't say most of you know this. It says most of this you know. Everyone in here knows most of what we're going to cover today. That's why we're going to fly through this and do this homework, because I've been teaching you this all semester. When I was a little boy and my dad taught me how to ride a bike, right? He rode behind that bike and it had one of those elongated kind of banana seats. You know what I'm talking about? Okay? And it had a little metal bar around the back of it, and you could hold on to that bar. And he'd hold on to that bar and run behind me, and I'm like, Dad, are you holding on? Yeah. You still holding on? Yeah. And then he's running behind me, let's go, are you still holding on? Yeah. And then I look back and I see he's not holding on, and I crash, because it scared the crap out of me, right? You're not holding on, you let go. I was riding the bike all by myself, but as soon as I mentally, didn't think he was there anymore, I was like, and I crashed it, All right, so listen to this. I've been teaching you polynomials all fetching semester. I just didn't call them polynomials. So let's not get scared of them now and crash, okay? Polynomials are everything you've done all semester. You're going to see this and you're like, you got to be kidding me. This is super easy. So we've been talking about this the entire book. You just didn't know it, okay? First of all, terms in a polynomial. We have defined a term a long time ago. We defined it like the second week of class. A term is separated by a plus or minus sign, and the sign before a term goes with it. So first of all, on these three problems, I want everybody to help me right now, okay? I'm going to write the first one on the board over here. All the others you're going to do straight in your book. Somebody read this to me. 12x squared. Read it.
Minus 7x.
12x squared minus 7x.
Plus y.
Plus y.
Minus 8.
Minus 8. Thank you. Okay? All right. So the first question, it says, how many terms in each poly? So how many terms in this polynomial? Everybody, 1, 2, 3. How many?
4.
4. Very good. There are 4 terms in here. All right? Very good. So you're going to write 4 terms. T-E-R-M-S. You're going to write that. And then I want you to identify each term. So what's the first term? What's the first term?
12x to the second.
12x squared. Very good. And look, we just put a comma there. Okay? What's our next term? Negative 7x. What's our next term? Y. And our next term? Negative 8. Very good. Those are all the terms. Really easy, okay? So let's do these next two. I'm just going to do them out loud. You guys read them on your paper. How many terms right here? 3 terms. What's the first one? 3x squared. Next one? Negative 2x. Last one? Negative 7. All right. This one. How many terms are in this expression? Number 3. Everybody. 4 terms. Very good. What's the first term?
42x squared.
42x to the 4th y squared. It's just one term. The next one is? 2x to the 3rd y. And the third one is? Negative xy. Don't forget the negative. And the last one is? Negative 3. Let's go to the next page. You guys cool? Okay? Very good. I'm excited for you to learn about polynomials today. Do you know why I'm excited for you to learn about polynomials today? Because you already know about them. I've been teaching you all semester. I've been holding on to the back of the bike and you didn't know it. Okay? And I let go. And you're like, ooh. And now you're like, this is like scary stuff, Brother Rich. No, it's not. They're called polynomials. So here's the first thing. It says up here, what is a polynomial? Everything in math is a polynomial. The number 7 is a polynomial. X is a polynomial. 2x is a polynomial. Everything up there is a freaking polynomial. All of those. Okay? You know, what's a polynomial? It's every term in math. A single number is a polynomial. A single variable is a polynomial. Multiple variables being added and subtracted, those are polynomials. What does the word mono mean? So right above monomial, what do you want to write? One term. One term. So if polynomial means many terms, monomial means one term. So write one term. Cool? Can't talk. Okay? Binomial. What are we going to write after binomial? Two terms. Write that above it. Just write two terms above that. Trinomial. What does that mean? Three terms. Okay? All right. So check this out. After you write that down, see all these terms in this column right here? It says which terms in the first column right here. I got x, I got 7, I got 7x, I got 7x squared, I got 7x squared over z. It says which terms in the first column move to the binomial column? Which ones? Think.
7x.
None.
Say it loud.
None.
Say it louder.
None of them.
Because they're all just one term.
They're all just one term. Brilliant. Brilliant. Yes, terms are separated by plus or minus signs. So right here, you put none. How many move to the trinomial column? None. None and none. So now what I want you to do in the binomial column, just give me like 3 examples of binomials. Let's write them down. You guys, you tell me, what's an example of a binomial?
X squared plus y.
X squared plus y. That's a great one. Give me another one.
3 plus 2x.
3 plus 2x. That's a great one. Give me one more.
2 plus 2.
What?
2 plus 2.
Now 2 plus 2 it combines to be 4. So we got to have different terms. What do you got?
You have to add x's and y's.
2 plus 2x.
2 plus 2x. Works for me. There you go. Those are all binomials. Okay, you guys cool with that?
Yeah.
Very good. Okay, a squared minus 7. There's another one. Okay, trinomial. Give me an example of a trinomial. Everybody, help me out.
2x squared plus 2x plus 2.
I love it. That's a perfect one. Give me another one. Come on. 3 terms.
2y minus 2
2y
plus 3x
plus 3x
minus 2.
minus 2. I love it. That's a great one. Yeah.
6y squared plus 7x squared equals 4.
Equals 4?
Equals 4.
No equals. That's an equation.
Plus 4. Plus 4.
Plus 4. There you go.
Same amount.
Okay, this is why we did this though. We had a couple of hiccups. It helps us not make those mistakes down the road. It was awesome. Okay, write all those down. Those are all perfect examples. Okay, while you're writing it down, it says, are there quadnomials, heptanomials, quadnomials, pentanomials, sextanomials, septanomials, octanomials? What do you think? Yes or no?
Yes, I think they're just under the umbrella of poly because poly's many.
Yes.
And they're just
So the answer is no. Are there? Right, no. Just write no there. And this is 4 or more terms equals polynomials. Absolutely. Good job, John. You did that right. Okay, so anything with 4 or more terms, we just call it a polynomial. Do you remember those families at church that named all their kids the same letter of the alphabet?
Yes.
Are you one of those families? Raise your hand. Tell the truth. Who's in it? Are you?
Yep.
Yeah. What is everybody?
Let's see. We've got Caden, Kale, my legal name, Kaya, and then they skipped out on my last sister, named her Danica.
Oh.
So they lost the whole thing, which makes it even more annoying.
There you go. There you go. You know, I remember this family in our ward, and they were all J's, right? And they were the simplest of names, you know, Julie, Jill, John, Jack, you know, you're like, oh. And so, after, you know, the first child they have Julie, okay? And the next child they have Jack, you know, okay, I remember Julie, I remember Jack. And they had John, and you're like, Julie, Jack, Jehoshaphat, somebody I can't remember. And so finally you're just like, just fetch it, they're the Smiths. You know, and we gave up on learning their names. We're like, you know, I remember Julie and John, but after 2 kids, I just call them the Smiths. It's the same thing with the family of polynomials, okay? A monomial is a binomial. My first name is Rich, my last name's a Llewellyn. My name is Rich, but I'm a Llewellyn. Every one of these is a polynomial. Those are polynomials, those are polynomials, those are polynomials. But when they have 1, 2, or 3 terms, we remember their first names. At 4 or more terms, we just say fetch it, and we call them all polynomials. We cool? All right. So right now, what I want you to do right here, look at these 3 problems. Let's do this together. What type of polynomial do we have right here? What type? Trinomial. Write that down. Okay? And it says, how many terms are there? 3 terms. So write that down. So it's a trinomial. It has 3 terms. And what are the terms? List the terms. 3x squared, negative x, Positive 7. Very good. Let's go to the next one. 42x squared minus 7. What type of polynomial is that?
Binomial.
It's a binomial. Very good. How many terms?
2.
What are the terms?
42x to the power of 2.
Very good.
And then negative 7.
Very good. Okay. And our final one. How many? So what type of polynomial is number 3? It's just a polynomial. How many terms are in it? 4 terms. What are the terms? You know this. 12x to the 4th y squared, negative 3x squared y, negative xy, and 8. You guys good? Wrap that up. Go to the next page. Okay? We're ripping through this. Hard or easy? Hard or easy? It's easy stuff, guys. And you know this. You're going to see some interesting things up here. Step number 3, it says evaluate a polynomial. What does it mean to evaluate a polynomial? It means to just substitute in the answer and do the math. It's so easy. Look up here. We've done this a bunch of times. X squared minus 5x plus 6. They tell you, evaluate the polynomial x squared minus 5x plus 6 when x equals negative 1. All right? Well, where there was an x, we put in a negative 1, right? So we have negative 1 squared minus 5 times negative 1 plus 6. Negative 1 squared is 1, right? Because negative 1 and negative 1 make 1, right? And negative 5 and negative 1 make positive 5 and plus 6. And we have 6 plus 6. And this equals what? 12. Say whoa if you got it right. Whoa. Whoa.
Wow.
Okay, listen to me. Is that hard or easy?
Easy.
Okay, it says, let's do a problem from the homework. Let's not. You know? You cool with that? I think we know how to do simple substitution. Let's skip that one. Okay? Let's go to number 4. Okay, by the way, look up here. See all these numbers? How there's like a 1, a 2, a 3, a 4? Every one of those numbers correlates with your homework tonight. So it'll be a section 1, a section 2, 3, 4 in your homework, and you'll be able to go back and be like, okay, the notes correlate with each of those numbers, all right? Like terms in a polynomial. Do we know what like terms are? Of course we do. Do we know how to combine like terms? Yes, we do. Please look up here. Define a like term. Terms with the same variable and degree combo. Please look at these 4 terms. 12x squared y squared plus 2x squared y minus 3xy minus 7. What are my like terms there?
X squared, y squared, plus 2x squared, y. There's 2.
Say it louder. There's none. There's no like terms. Please look up here. X squared, y squared. Is that an x squared, y squared? Everybody, come on. Is that an x squared, y squared? Is that?
No.
Is that?
No.
No. X squared, y. Is that an x squared, y? Okay, do you have any like terms there? No, you don't. So write none. There's just none. There's no like terms. Now this next one, we definitely have like terms. And our tool with like terms is the symbol method, right? You pick your symbols, circles, single underlines, double underlines, triple underlines, squares, triangles, whatever you want to do. Somebody read that problem to me. Read it fast. Here we go. Well,
squared,
go ahead. Yep.
y squared plus 2x squared y minus 3xy minus 7x squared y squared minus 2xy plus 8.
Okay. All eyes up here, please. Let's do this rapid. Okay? Is there anything new going on here? Do we know how to do this? Yes, we do. Okay, look up here. I got an x squared y squared. Is this an x squared y squared?
No.
Is this?
No.
Is this?
Yes.
Is this?
No.
Is this?
No.
How many terms in this total polynomial right now?
6.
There are 6, right? Okay, let's see what we can do with this, okay? 12 and negative 7 make what? 5x squared y squared. Cross them out so we don't look at them anymore, okay? I got, look at this, I'm going to triple underline, 2x squared y. Is that an x squared y?
No.
Is that?
Yes.
Is that? So what do we do with that? Drop it in the answer, exactly. Cross it out, be done with it, okay? Negative 3xy, negative 2xy. Those are like terms. That makes negative 5xy, and positive 8 comes on along for the ride, and now you have a 5-term polynomial, and you're done. You combine like terms with polynomials. You good? We know how to do this because we learned how to do this a long time ago. We know how to combine like terms because we know polynomials. We just didn't call them polynomials. Let's go to the next one. Coefficient of terms in a polynomial. A coefficient equals the big number. Write that down in that open space. Coefficient equals the big number. Okay, so in every term, the big number is the coefficient. All right, need your help. Identify the coefficient. We're going to do this rapidly. Identify the coefficient of the first term. So right now, just right here, write coefficient. Just write coefficient. And then right here, what is this? 16. This one. Negative 1. What's this one? 2. This one? Negative 1. This one? Negative 7. Done. Hard or easy?
Simple.
Super simple. Okay? All right. Degrees of terms and degree of the polynomial. So we talked about the big number, coefficient. Now we need to talk about the little number in polynomials. Okay? we have to understand that the degree of each term, please listen, is the sum of the degrees of the variables in that term. The degree of a poly, the entire polynomial, is the greatest degree of any term in the poly. So what I want you to do right now, just right here in this column, right here, I want you to write degree of term, and down here I want you to write degree of poly, okay? Degree of term, degree of poly. I'll write it as well, okay? So we're going to have degree of term, and you can write degree of the entire poly. So just write degree of poly, right? So now though, I want you to just, now that you have those columns written, I want you to write degree of term. What's the degree of this first term? Everybody help me, come on.
5.
5. What's the degree of this term?
3.
3. What's the degree of this term?
1.
Nope. The sum of the degrees of the variables. I want you to write, what's the degree of the x? So look at, you got 2xy. Look at this, 2xy. You're going to write a little one here and a little one there, because that's true. Do you agree?
Yeah.
Okay? So now come back to that. What's the degree of that term?
2.
It's 2.
Isn't that 3 though? Because doesn't 2 have a 1 technically?
The degree of the variables. 2 is not a variable.
Oh, you're right.
You're cool. It's a good question, right? Okay? 2. What's the degree of this term? 1. What's the degree of this term? It's 0. And right next to that 7, I want you to write negative 7. I want you to write x to the 0. I just want you to do it. Why? Because it's true. Because the degree of the variable, well, there is no variable. So if we wrote a variable in there, we'd have to write degree 0 because anything to the 0 power equals what? 1. And 1 times anything remains the same. Very good. Okay. All right, let's do this next one. Quickly. We got to hurry. Degree?
3.
Oh, by the way, what is the degree of the entire polynomial? The degree of the entire polynomial, what was it? It's the greatest degree of any one term. What is it? It's 5. So that's a degree 5 polynomial. Okay, let's do this one really quick, all of you. What's the degree of the first term?
3.
3. The second term?
3.
Good job. Write a 2 and a 1 there. And this one is also 3. And this one is? This one is?
1.
And this last one is?
0.
0. What's the degree of the entire polynomial? It's 3, because that was the greatest degree of any one term. Hard or easy? Jump to the next page. Let's go. You gotta fly. You got a little bit more to do, okay? Okay. These next two are pretty simple, but the last one's kind of a little weird, okay? Sometimes weird confuses you. Arrange a polynomial in descending order. Oftentimes the answer to a polynomial will be written in descending order. What does descending mean? It means to go from the largest down to the smallest. By what? By degree. So write degree there, not by coefficient. It's by degree, not by the big number, it's by the small number, okay? So descending order is by degree, not by coefficient. So let's look at this problem right here. Arrange each term in this poly in descending order. So my first term written should be what? 2x to the 5th. Then my next term should be minus 4x to the 3rd. Then plus 12x squared plus x minus 3. We cool? In descending order, right? Because that will give you, what's that?
Why is it in descending order?
Because it's by degree. So you ended up with, read it to me again. We have 2x to the 5th. What's my next one? Help me. Hurry, guys.
Negative 4 to the x to the
Negative 4x to the 3rd. What's my next one?
Plus x.
Plus 12x.
12x to the 2nd. What's my next one?
X.
Huh?
x.
X, what about x? Plus or minus? You gotta have, you're adding and subtracting. What are we doing?
Plus 6.
Plus x
Just easier to read.
Minus 3.
Negative 3.
minus 3. Okay? Now look up here. 5, 3, 2, 1, x to the 0. 5, 3, 2, 1, 0. That's descending order by degree. Make sense? Okay? All right, last one. Missing terms in a polynomial. On this one right here, I want you to do something. One time, an angel visited Adam, and he asked him, "Why do you make sacrifices?" And Adam said, "I know not, except the Lord commanded me." So on this next one, I don't want you to ask why. Just do it. Okay? If you ask why, you're going to be confused as fetch, and so I don't want you to be fetched up. So I just want you to do it. Okay? Look up here, please. Read the problem to me. Somebody go fast.
12x to the 5th minus 7x to the 4th plus 2x squared minus x minus 1.
Minus 1?
Yep.
Okay. So, look up here. I have a degree of 5, a degree of 4, a degree of 2, 1, and 0. What degree am I missing? 3. So what I do is I rewrite this 12x to the 5th minus 7x to the 4th, and then how many x to the 3rds do I have? I have none. So I write plus 0x to the 3rd. It's called a placeholder. It's just a placeholder for the x to the 3rds because I don't have any. And then I write the rest plus 2x squared minus x minus 1, and I'm done. Don't ask why, just do it. Okay? It's called missing terms, all right? You gonna do it all the time? Nope, just when you're asked to, okay? And on this section right here, you're gonna be asked to, okay? Listen, we're almost done. We're almost done, okay? Please listen, don't close your books. We are done with this section, but I want you to jump quickly to section 4.4. Like, you gotta be kidding me, brother. No, I'm not kidding you. And I'll tell you why I'm not kidding you. Because see section 4? Look at it. There's the explanatory part. It's just those two problems. The addition and subtraction of polynomials. You know how to do it. It's called distribute parentheses, combine like terms. You learned that on the second week of class, or maybe the third week of class, okay? Distribute parentheses, combine like terms, okay? So I'm going to write this problem on the board real quick. Somebody read it to me. X squared minus 5x plus 6 in parentheses. What's the next one?
Plus 12x squared minus 7x minus 8.
Minus 7x minus what? 8, okay? This is in parentheses. I have x squared minus 5x plus 6. This is in parentheses, and I have plus. Look at this. Is this a polynomial? Is that a polynomial?
Yes.
And they're being what?
Added.
Ooh, the addition of polynomials. Do I need this parentheses? Why not? Because the distributor is 1, and 1 times anything remains the same, so this ends up just being x squared minus 5x plus 6. Do I need this parentheses?
Nope.
I don't need that one either, so I have plus 12x squared minus 7x minus 8. And now I can just combine like terms. X squared and 12x squared make 13x squared. Write this down. Negative 5x, negative 7x makes negative 12x, and 6 and 9 minus 8 makes minus 2, and I'm done. I know how to add polys because I learned this a long time ago, because you're freaking smart. Look at this. Subtraction of polys. Oh, is this a poly? Is that a poly? Are they being subtracted? Do I need the first parentheses?
No.
No, because?
The distributor.
Okay, so come on over here. What is the first parentheses? 4x squared what?
Minus 5x plus 2.
Thank you. Minus what?
Minus, in parentheses, 6x squared minus 7x minus 7.
Beautiful. Thank you. All eyes up here. Check it out. Last thing today. I don't need that parentheses because it's just a 1. Do I need this parentheses? Yes, I do, because the negative has to go to all these, so I end up with negative 6x squared plus 7x plus 7. Now I combine like terms. 4x squared minus 6x squared makes negative 2x squared. Negative 5x, positive 7x makes plus 2x. And 2 and 7 make plus 9, and I'm done. I know how to subtract polynomials because I know how to distribute parentheses and combine like terms. You will have a handful of problems in this section tonight. These 3 sections are all due Wednesday. Please understand this. This is the price you're going to pay to buy yourself some time when it's harder and buy yourself the last day off to totally focus on the last test. You guys cool? Okay, you guys are awesome. I'll see you next time.
You only have one more